Hi, I'm Todd Daniels with Emerson Swan, and I'm here to talk to you about an important yet often overlooked component in a hydronic heating system. That's the pressure reducing valve. Here's a conventional hydronic heating system, and our pressure reducing valve typically is located right here where the incoming municipal water meets and feeds the hydronic heating system. The pressure reducing valve is often combined with and sold and installed along with a backflow preventer, which, should there be a sudden drop in the municipal pressure, system fluid does not flow into the potable water system. Now, pressure reducing valve and backflow preventer combinations have many shapes and forms. This is the Taco 3492 combination valve. And some of the features of the 3492 are, number one, it has an oversized screen, which actually will reduce callbacks due to clogging of the backflow preventer. Now, this screen is about 45% larger than competing brands. Some of the other features are a robust adjustment screw and a locking fast fill lever. An upgrade to the 3492 is actually the Taco 3450 combination. Obviously a totally different configuration, but it has cartridge replacements for both the pressure reducing valve and the backflow preventer. Let's take a look at the job of the pressure reducing valve. Now, as the name suggests, it's designed to reduce the pressure from the municipal pressure, which is typically a higher pressure, to a lower pressure of the hydronic system. And typically off the shelf, like I mentioned, it's 12 psi. So why is it 12 psi? Why isn't it some other arbitrary number? We need to know one quick fact, and that is the weight of 2.31 feet or 28 inches of water column registers 1 pound per square inch on a pressure gauge. Now, that's important to know, because if we take our 12 psi, typically sold as a pressure reducing valve, we multiply it by 2.31 feet, and that gives us 27.72 feet of lift. So the job really of the pressure reducing valve, not only to reduce pressure, but to give enough pressure to overcome what we call static head in the system. So 28 feet in a conventional home will raise that water column from the pressure reducing valve up approximately 3/4 or to the top of a hydronic heating system. Now, it would stand to reason that if the building was taller, we would actually need more pressure. We take the vertical height of the building and we divide that by 2.31 feet, and we have an approximate pressure to fill the system at. Now, why is this important? It's important because we need to keep radiation or whatever type of heat emitter pressurized at the upper level. Because they say in hydronics, the old adage is, if there is air, there is no flow. So we need to make sure that that pressure reducing valve is lifting that column of water to the top of the heating system so that we have a positive pressure at the top. One caveat as far as system pressure goes, although 12 psi will probably be enough for a 2 or 3 story home, with the advent of modulating condensing gas-fired boilers, some of the water pressure safety devices require a higher pressure in the system, say 12 or 18 psi. And that's a quick look at the pressure reducing valve and the job of a pressure reducing valve. Now, to recap, its sole job is to reduce pressure from the municipal system and to overcome the static head of an existing home or building. That is not the job of the circulator, which is a common misconception. It's the role of the pressure reducing valve to overcome that static head. I hope you've learned something today. I'm Todd Daniels with Emerson Swan. Thanks for tuning in.